Today I will explain various types of insulator, that is based upon the operating voltage. The insulator are classified as four types: pin type insulator, suspension or disc type insulator, strain type insulator, and shackle insulator. And causes of failure of insulator, that is the definition of flashover, puncture, and then the string efficiency. Coming to the types of insulator, depending upon the operating voltage and the properties of the insulator, the mainly classified into four types. The first one is pin type insulator. The second one, suspension type insulator. The another name of suspension type insulator is disc type insulator. Third one, strain type insulator, and the fourth one is shackle type insulator. The pin type insulator, they are used up to 33 kV. That is the both transmission as well as for the distribution purpose up to 33 kV. Beyond 33 kV, economically it is not satisfied. That is the cost is increased and the size of the insulator is also increased. And the suspension type insulator, we can use from 11 kV to up to any operating voltage. That is the each disc, the capacity is 11 kV. Based upon the operating voltage, n number of discs are connected in series. And the strain type insulator, here the each disc, the capacity is for 11 kV, but it is used only for up to the 11 kV. Beyond 11 kV, economically the cost is more. But based upon the operating voltage, the strain type insulator is also connected for n number of discs in series. Wherever the dead zone, wherever cross section is there, wherever the tension is more, for the particular places they are used for the strain type insulator. Another one is for the shackle insulator. It is used for the distribution purpose. That is 3-phase 440 volt 3-wire system or 4-wire system, and then the single phase we can use up to 11 kV. But the maximum this shackle type insulator, they are preferred only for the distribution purpose. That is the first one, the pin type insulator. Here the pin type insulator, the top of the portion is called as the groove. The upper portion is groove, that is housing the conductor. This the conductor passes through this groove and bound by the any lead wire. Here this is in the particular places, that is the laid on the conductor, the like that, and the same conductor material they are twisted, that is represent for the any lead wire. Here the material they are used for the aluminum conductor. Actually in the overhead transmission line or distribution line, the conductor, the material they are used for ACSR conductor, that is aluminum conductor, steel reinforced. This the conductor is laid on the groove of the conductor, the housing purpose, and without moving from left hand and right hand side, they are twisted for the same conductor material, that is represent for the any lead wire. The pin type insulator is used up to 33 kV. It is used for both distribution as well as for the transmission purpose. The distribution purpose in the sense, that is 3-phase 440 volt, and the transmission purpose 11 kV and then 33 kV. Up to 33 kV they are used for the pin type insulator. Beyond 33 kV, economically it is not satisfied. And another one, the size of the insulator is also the huge. The size of the insulator is also huge. And the one more drawback, this the pin type insulator is highly affected for the lightning compared to the suspension or disc type insulator. Actually here the material they are used for porcelain material. They are used for the porcelain material. Before choosing the insulator, they are choosing without cracking of the insulator. The top of the material they are applied for the varnishes. This is shed or petticoats. The top they are applied for the varnishes, the cementing, and the galvanized steel pin. It is the fixed to the cross arms. The bottom portion, this the pin is fixed to the cross arms with the help of bolt nut, and the top of the groove, the housing of the conductor with the same material, that is with the same material in the sense aluminum material. The pin type insulator is used for both transmission as well as for the distribution purpose. That is the distribution purpose 3-phase 440 volt, and the transmission purpose used for 11 and then 33 kV. Beyond 33 kV, economically it is not satisfied. And another one, the size of the insulator is also high. Once the size of the insulator is increased, means it is affected for the mechanical stress. It is affected for the supporting structure. And the bottom of the portion, that is the galvanized steel pin, is connected to the cross arms fixed with the help of bolt nut. And at the top of the portion, that is the upper portion, in the groove, the conductor is placed on the housing of the conductor with the help of annealed wire. That is the material used for the same conductor material, that is the ACSR conductor aluminum material is used. And beyond 33 kV, this is the major drawback. Economically, it is not satisfied, and the size of the insulator is also large. The next one is for the second one is suspension type insulator. What are the drawback in the pin type insulator that overcome in the suspension type of insulator? That is, the cost of pin type insulator is uneconomical at higher operating voltage, that is beyond 33 kV. The suspension type insulator is used from 33 kV to up to any operating voltage, that is we can use up to 765 kV. This suspension type insulator, the another name is called as a disc type insulator. It is used beyond 33 kV to up to 765 kV. Each disc, the capacity is for 11 kV. Based upon the operating voltage, n number of discs are connected in series. For example, how they are calculated, how many number of discs are required in overhead transmission line. For example, you can take 400 kV transmission line. For example, you can take 400 kV transmission line. The formula is that is the phase voltage by disc capacity, that is the disc capacity one additional disc or spare disc, for 400 kV transmission line, that is you can take the phase voltage 400 by root 3, the disc capacity is 11 kV, one additional disc or spare disc, that is we are getting approximately equal to 22 discs, that is 22 discs are connected in series, that is phase voltage by disc capacity plus one spare disc or additional disc, that is 400 kV transmission line. The phase voltage is 400 by root 3 divided by the disc capacity is the individual disc capacity is 11 kV plus one additional disc or spare disc. The total number of discs is required for 22 discs. That is 22 discs are connected in series, that is represent for the string of insulator, Here, the number of the disc, the material used for the porcelain material or the tungsten, the glass material, it is connected in the series with the help of metallic link. That is one disc to another disc, the connecting with the help of metallic links. Like that, if you are connected, means that is represent for the string of insulator. In the suspension type insulator, the one end is, that is the bottom end connected for the conductor, and the another end is connected for the cross arm side. That is the bottom end is connected for the line conductor, and the another end is connected for the supporting structure side. Here, based upon the operating voltage, you can design for n number of discs are connected in series. And suppose if we are connected in the 3 discs are connected in series, that is 33 kV transmission line. Suppose in the particular line, we can increase the operating voltage, that is 66 kV. We no need to go for the one more thing. Additionally, we can add for the number of discs in series. How we can calculate it means based upon the formula, that is the phase voltage for 66 kV, that is 66 by root 3 by the disc capacity, that is the individual disc capacity 11 kV plus one additional disc or one spare disc. Like that, we can add it n number of discs in series. And one more advantages in the suspension type insulator, in the string of insulator, if any one of the disc is failure, that is the whole string is not useless, we can replace the only particular the insulator, that is which insulator is damaged, we can replace only those insulator, remaining all the insulator is for the healthy condition. Generally, this suspension type or disc type insulator is used for steel towers, that is for 66 kV, 132 kV, 220, 400, and then 765 kV. We can use it for suspension type insulator. Previously the material they are used for the porcelain material, but at present they are used for the toughened glass material. In porcelain material, with our naked eye it is not visible any air bubbles are formed at the time of coating or any minute cracks are there. But the toughened glass material, it is visible with our naked eye clearly if any air bubbles are there or any the minute amount of the crack is available. And the disc type insulator or suspension type insulator are used in horizontal plane, but the disc are connected in series, but the position, that is the tower, the position, the steel tower, the position is the horizontal position. That is the disc type insulator are connected in the horizontal plane. That is the suspension type insulator beyond 33 kV, that is the pin type insulator, economically it is not satisfied. And another one, the size of the insulator is also large, due to that the weight is increased, mechanically it is not satisfied. At that time we will go for the suspension type insulator or disc type the insulator. That is the each disc the capacity is for the 11 kV based upon the operating voltage. N number of discs are connected in series. How we can choose number of discs is required means based upon the formula, that is phase voltage by disc capacity plus one additional disc or spare disc. For example, you can take 400 kV transmission line, that is 400 by root 3, that is phase value, by the disc capacity is 11 kV plus one additional disc or spare disc. That is we are getting beyond the 0.5 or 0.5 above, we can round up the next digit, or less than the 0.5 means we can round up the below value. That is for 400 kV transmission line, how many number of discs are connected in series? That is 22 discs are connected in series. Here the metallic discs are connected with the help of metallic links. That is the material used for the porcelain material or toughened glass material. The one end is connected for the conductor, the another end is connected for the supporting structure. If the operating voltage is increased means just we can add for the one more new disc in series. If any one of the disc is failure in the string of insulator, that is we are connected n number of discs are connected in series means that is represent for the string. If any one of the insulator is failure means the whole string is not useless, only we can replace the particular disc. And this the disc type insulator is connected in the position is horizontal plane, that is based upon the supporting structure. Don't consider for the insulator, only considered for the supporting structure. That is the suspension type insulator are connected in the horizontal plane. And the next one, third one is strain type insulator. This type of insulator is mainly used for wherever the great tension, that is at the end of dead zone or the cross section or corner, for the particular places they are used for the strain type insulator. It is similar to the suspension type insulator, but it is connected in the vertical plane, that is the structure position. It is connected in the vertical plane. It is used for transmission line. The each disc is for 11 kV. The each disc is capacity for the 11 kV, but the beyond 11 kV economically it is not satisfied. Beyond 11 kV economically it is not satisfied. This strain type insulator only we are used for wherever the great tension is there, that is dead zone or the corner or the curved shape. And similarly, if the operating voltage is increased means n number of discs are connected in series, we can use the same formula, that is phase voltage by the disc capacity plus one additional disc or spare disc, one additional disc or spare disc. And similarly, if any of the disc is failure means the whole string is not useless, we can replace only the which disc is the damaged, we can replace only for the those discs, remaining all is considered for the healthy disc, remaining all is considered for the healthy disc. Here the strain type insulator is only used for the wherever the tension is more, that is at the dead zone or the corner or curved space. This is used for the transmission line, and the each disc capacity is for 11 kV. Beyond 11 kV economically it is not satisfied comparing to the suspension type insulator. but the based upon the operating voltage, we can add for number of disc in series. If the operating voltage is increased means we can add for one more disc in the series. It is similar to the suspension type insulator. The calculation number of disc is required in series. The same formula, that is phase voltage by the disc capacity, one additional disc or spare disc, one additional disc or spare disc. But the connection of the position is vertical plane. The position is connected in the vertical position, and you can see here this is the tension is presented, that is this is the dead zone or corner of the position. And the next one, suspension type insulator. This type of the suspension insulator is mainly used for the distribution purpose, that is 3-phase 440 volt 3-phase 3-wire system or 3-phase 4-wire system. This is connected in both horizontal as well as for the vertical position. Just this one we can fix it in the poles with the help of bolt net. This is used for wooden pole, steel pole, RCC pole or PSCC pole. It is not applicable for the transmission line. The shackle type insulator is used for the normal position, the dead zone, wherever the tension is there. It is applicable for distribution purpose. Just we can fix it in the supporting structure, that is the pole, with the help of bolt net, but it is connected in the any position, that is horizontal or the vertical plane, horizontal or vertical position. Here in these the places we can lay down the conductor. In these places we can lay down the conductor. And these are the 4 types of insulator, that is pin type insulator, suspension or disc type insulator, strain type insulator or shackle type insulator. The pin type insulator is used for both distribution as well as for the transmission purpose. The suspension type insulator is used for the transmission purpose line for 11 kV up to the 765 kV. And strain type insulator is used in the transmission line wherever the dead zone or cross section, wherever the mechanical stress is presented. And the shackle type insulator is purely used for the distribution purpose. It is connected in the any position, that is horizontal or vertical plane. And causes of failure of the insulator. Suppose the insulator is failure means what are the problem is arises. Generally, once the insulator is failure in the for both transmission as well as for the distribution purpose, that is cracking of insulator. The insulator should be cracked. And another one, use of defective insulator material in a string of insulator. At the time of erection, that is if you are used for the porcelain material, any air bubbles or any air crack is there, it is not visible with our naked eyes. Once we are using in a string of insulator, that is a defective material, due to that the puncture it should be taken place, that is the occurrence of the puncture. Once the puncture is carried in the particular the insulator, the voltage is not operating for the fully, and due to the falling of large bolts, generally in the open atmosphere, in the all the conductor, the top the laying on the bolts with heavy weights, at that time the two conductors are close to each other, that is arc in between the conductor. Due to that the insulators are failure. And the next one, due to improper glaze, that is at the time of erection, any rough surface is formed on the insulator, that is observed for the water particle, moisture and then alkaline particle. Due to that the insulators are failure. That is before we are choosing the insulator, it is considered for the smooth surface without the material, without observed for the water particle, moisture, alkalis and then gas particle. If it is observed means the short circuit is observed, voltage drop is also taken place and the insulator gets failure. And the flashover occurred due to the unequal expansion of the porcelain material and due to mechanical stress. We are using the material, the weight is increased, that is the conductor weight is increased and the stress is presented on the insulator. At that time the insulator gets failure. These are the various causes of failure of insulators. And the definition of the flashover, that is formation of arc between the line conductor and supporting pin of the insulator is called as flashover. Suppose this is the supporting structure. We can take that is either disc type insulator or strain type insulator. That is the n number of discs are connected in series with the help of the metallic link. Now this is the transmission line is there in the particular position, that is the arc between the conductor and supporting pin that represent for the flashover. Due to the flashover, the insulator will not work fully to its rated capacity. For example, you can take in the particular the transmission line, the operating voltage is for 33 kV. Actually, in the particular the insulator, the flow of the operating voltage is that is 32.4 kV or 32.8 kV, so on, etc. Once the flashover is taken place, that is in between conductor and the supporting structure, the voltage is not operating fully. That is the only in the particular line the operating voltage is either 21 kV or 24 kV or 18 kV, so on, etc. There are the two types of flashover is there. One is for dry flashover. One is for the dry flashover, that is free from the liquid. Another one is for the wet flashover. The wet flashover, that is either the weather condition in the rainy days. The flashover is taken, it is not in the season based, it is taken in the regularly. That is the dry flashover in the sense free from the liquid. The wet flashover means it is occurred in the rainy days due to the climate conditions. And the next one is the puncture, that is the flow of discharge from conductor to pin through the body of insulator is called as puncture. Suppose the over a transmission line, the conductors are laid on the groove. That is, this is the supporting structure. You can use either pole or tower. In that, the supporting structure we are connected for the pin type insulator. In the cross arms, that is fixed for the insulator with the help of bolt net. The top of the insulator we are taken for the conductor. In the groove of the insulator we are taken for the conductor. Now here the flashover is taken place. Within fraction of second, it should flow through the ground particle through the body of the insulator. That is represent for the puncture. Due to the occurrence of puncture, the insulators get permanently damaged. Due to the occurrence of the puncture, the insulator gets permanently damaged. In order to avoid the puncture, the insulator may be provided with sufficient thickness. That is the insulator material they are used for two types of material in the overhead and then distribution line. That is porcelain material and then toughened glass material. At present, for 400 and then 765 kV, we are used only for the toughened glass material to avoid the flashover and then puncture. If any air bubble or any crack is there in toughened glass material, it is visible with our naked eye. At the time of erection itself, we are not used those type of materials. And the next one, the string efficiency, that is defined as the ratio of voltage across whole string to the product of number of disc into voltage across the disc nearest to the conductor. And percentage string efficiency is represent for multiply with respect to 100. That is, this n is represent for number of discs are connected in series. That is, the string efficiency is defined as the ratio of voltage across the whole string to the product of number of discs and then voltage across the disc nearest to the conductor. That is, this string efficiency we can calculate it in the suspension type insulator or disc type insulator. For example, you can take, this is the supporting structure. We can connect the n number of discs in series. That is, the three discs are connected in series. That is voltage across the whole string. This is, we can take the string efficiency, that is 33 kV by the n. How many number of discs are connected in series? That is, the three discs are connected in series into voltage across the disc nearest to the conductor. That is, indeed all the disc it is not maintained for the same voltage. Here nearer to the conductor side, the voltage is maximum, and goes on to the cross arm side, the voltage it should be minimum. For example, you can take here the operating voltage is 31.2 volt into 100. This is for the string efficiency. In this class, we have discussed for the types of insulator based upon the operating voltage, based upon the mechanical stress, or based upon the properties. The insulators are classified for 4 types: pin type insulator, suspension type or disc type insulator, strain type insulator, and then Shackle insulator. The pin type insulator we can use up to 33 kV. Beyond 33 kV, economically it is not satisfied. And the size of the insulator is also lump size or big size. That is, the pin type insulator is used for distribution purpose and then transmission line, that is 11 and then 33 kV. That is, the one end is connected for the cross arm side fitted with the help of bolt net, and another end is connected for the conductor. That is, the top of the upper portion is groove, in that the conductor is laid, the fitted with the help of annealed wire. That is the same material. We are used in the distribution and then transmission line. The material used for the ACSR conductor, that is aluminum conductor, steel reinforced. The same aluminum material are used for the twisting of the conductor without moving from the groove. And the second one is the suspension type insulator. The another name of suspension type insulator is the disc type insulator. The each disc, the capacity is for the 11 kV. In pin type insulator, that is beyond 33 kV, economically it is not satisfied. At the time you can go for the suspension type or the disc type insulator. Based upon the operating voltage, we can connect it for n number of discs in series. That is how we can calculate it, means base voltage by disc capacity plus one additional disc or spare disc, one additional disc or spare disc. Suppose in a string of insulator, that is in a string it consists of either 5 or 6 or n number of insulator are connected in series based upon the operating voltage. If any one of the disc is damaged or any one of the disc is failure, means the whole disc is not useless. Only we can replace the particular disc. The remaining disc is for the healthy condition. And one more thing, suppose if the operating voltage is increased, simply we can add for the, based upon the addition of the operating voltage, we can connect a number of discs in series. And another one, the strain type insulator. It is similar to the disc type insulator, that is used in the wherever the tension is more, dead zone, cross section, and then the curved position. But it is used for the transmission line, that is the individual disc capacity is 11 kV. Beyond 11 kV, economically it is not satisfied. But it is also similar thing, based upon the operating voltage, we can connect it for n number of disc in series, n number of disc in series. The same, if any one of the disc is failure, means the whole string is not useless. We can replace the particular disc, remaining all disc is for the healthy condition. And the last one is for the shackle type insulator, that is used for distribution purpose. But the suspension type insulator is used in the horizontal plane. Strain type insulator is used in the vertical plane. But the shackle type insulator is used for any position, horizontal or vertical position. Simply it is fitted on the supporting structure, the pole, with the help of bolt net. It is connected in either vertical plane or horizontal plane. In that, the insulator we are twisted for the conductor, taken for the three phase 440 volts, 3-phase 440 volt. And the definition of the flashover, the flashover and puncture is affected for the failure of insulator, that is the causes of failure of insulator. The flashover in the sense, the formation of arc between line conductor and supporting pin insulator at that particular place, that is in between conductor to insulator, that is represent for the flashover. Due to that, the flashover in the insulator, the fully voltage is not operated. For example, you can take 33 kV. This 33 kV is not the flowing in the particular insulator at the time of flashover. And there are two types of flashover is there. One is for the dry flashover, next one is for the wet flashover. And puncture, once the flashover is taken place, that it should be discharged to the ground through the body of the insulator. That is the flow of discharge from conductor pin to through the body of the insulator is called as puncture. That is, at that time the insulator is fully destroyed. To avoid that one, we are using for the size of the insulator, the thickness is more. To avoid the puncture, we can use for the insulator thickness is more. And the next one, the string efficiency, that is defined as the ratio of voltage across whole string by product of number of disc into voltage across the disc nearest to the conductor into 100. Voltage across the disc nearest to the conductor into 100.